Assalamualaikum and good morning to our lecturers, Sabari, class monitor Eric, and to all my friends. Today, I want to present about our product. Our product is telephone. The table of content. First, introduction and objective. Number 2, product to be studied. Number 3, redesign to the product. Number 4, break-even point and chart. Number 5, environment and sustainability. Number 6, discussion. And number 7, reference and appendix. After that, include introduction and objective. It also include product description, right, critique, classification of each part, estimate installation time and design efficiency, and is also the same as the second thing. The first content is an introduction. We are charged to find product. To study is based on the design for manufacture and installation study guideline. Number 3, feature for a product is called telephone, and last, not of use, but is an old design, thus making the method solid. Objective: to be able to analyze the assembly efficiency of the old design. Number 2, to be able to critique the old design from an assembly point of view. Number 3, to design a new and improved design based on the old design. And the last, to be able to state the benefit and improvement of the new design. This is a code telephone product and part number. This is a number of the part table that contain the part ID numbers and quantity. The next content is the selected product. Therefore, there is product tree structure. It has a telephone body, code call, and handset body. First, the telephone body has part the button, electrical board, buzzer, memory button, back cover, screw M3, switch hole, rubber, 0.6 and last step beside the code call does have the part, and the last, the handset body has part like a speaker, microphone, handset cover, and screw M4. Next, part critique. First, to be used as the base of the product, strength or weakness, to manage slot for shaft to put in. Number 2, to deal in numbers, to call. Strength or weakness is rubbery for non-slip, feel, and also flexible. Number 3, service as the cover for the internal part of the telephone. Strength or weakness consists of too many shaft or slot that is hard to insert to the counterparts. Last, service as the cover for the internal part of the handset. Strength or weakness is too many shaft and slot that make assembly hard.
Thank you for Sharfana. Now I will be continue about part classification. First part is body. The thickness of body is 200 and size 118. And then alpha is rotation from axis X. For rotation for body is for alpha body is 316 degree and beta 360 degree, beta from the axis Y rotation. And then alpha rotation degrees alpha plus beta is 720. And then manual handling, 2 hand for manipulation. You need to use 2 hand to manipulate the body part. And then part present no additional difficulty. And then code for body is 18.3 and time is 5.6. And then manual insertion, part secure immediately. And then part and associated tool can easily to reach the desired location. Screw tightening immediately after insertion. and then easy to align and position with no torsional resistance. The code is 38 and time 6. And then base thickness is 214 and size 118mm. Alpha 316 degree and beta 316 degree. Alpha plus beta 720 degree. For manual handling, two hand manipulation, and then part present to addition difficulty. Code same 83 and time 5.6. Manual insertion, part secure immediately. Then part and assisted tool can be easily to reach the desired location. No screw operation or plastic domation immediately after insertion, and then easy to align and position with no resisting insertion. The code is 13 times 2. Die button thickness is 14mm and size 85mm. Alpha 118 and beta 316 degree. Alpha plus beta 514. Manual handling, just use the one hand to manipulation, easy to grasp and manipulate. And then code is 20 times 1.8. And then manual insertion, part secure immediately. Part and accessory to can be easily to reach the desired location. No screw operation or plastic domation immediately after insertion. Easy to align position with no resistance or insertion. And then code 13 times 2. Next part is memory and volume button. Thickness 14, size 85mm. Alpha 118, beta 316. Alpha plus beta 514 degree. And then manual handling, just one hand to manipulation, easy to grasp and manipulate. Code 20 times 1.8. Manual insertion, part secure immediately. Part insertion can be easily to reach the desired location. No screw operation or plastic domation immediately after the insertion. And then easy to align and position with no resistance and to insertion. Code 13 and times 2. Handset cover, thickness 116mm, size 185mm. Alpha 316, beta 316 and alpha plus beta 720 degrees. Manual handling, just one hand handling, one hand to manipulation and manipulate, and easy to grasp and manipulation. Then code 13 times 1.1995. And then part not secure immediately. For manual insertion, part is not secure immediately. Part is to can be easy to reach to the desired location after assembly. No holding down requirement required. And then easy to align to position during assembly. Resisting to insertion. Code 10 times 2.5. Then is a estimate assembly time for all design. Total average is for estimate time is 386.49 second. And then this is a design efficiency for the old design. So our design efficiency is 21.64. Then product redesign, we choose the more part to be combined or to redesign the part. Now I can explain about design and classification. we combine the two part. The part is dry button and membrane button. Why we combine this part? Because this part use the same material, rubber material, and then the manual handling and manual sensing is totally same, but thickness and size different. And then after then next part is a body. The old design use the screw operation, but we redesign and we use the snap fit, no screw operation. Then we combine the body and stand. Why we combine? Because the material 100% same plastic, and then manual head for manual section after redesign, and then this not have not they use not use the screw, and then the screw is same. And then after we combine, it can be reduced the total part, and after we reduce the total part, we can be reduce the estimate assembly time. This is estimate assembly time after the design 202.62 second, and then this design efficiency of a resistant product. For design 21.64, and after redesign 33.33 this efficiency. And that's all for me. And then now I can pass to Eric to continue this presentation. Thank you.
Thank you, Faris. I will now continue the presentation. Okay. In my part of the presentation, I will be discussing about the cost and the break-even point about our project. Okay. Here are the costs. There are two types of costs, which is the fixed and variable cost. Fixed cost, fixed cost, there consists of rent, which is 2,500 ringgit, salary, which is 5,000 ringgit, and if we total it up, it is 7,500 ringgit. Next is the variable cost. The variable cost comes in many ways, but in this case, there are three types of variable costs. Firstly is the plastic, which costs around 5 ringgit per unit, and then the rubber, which is around 1 ringgit, and then the electrical parts, which is 6 ringgit. And then if we total it up, we have 12 ringgit. And then to produce 1 unit, it comes at the price which is 150 ringgit. Okay, next is the break-even points, and in terms of Malaysian ringgit, F, which is fixed cost, which comes at 7,500 ringgit. V, which is a variable cost, which is around 12 ringgit, and P, which is around 150 ringgit. So to calculate the break-even points in terms of Malaysian ringgit, we first divide 7,500 ringgit by 1, which is 1 unit, minus 12, which is divided by 150, and here we can get around 93,750 ringgit. That is for Malaysian ringgit. Now is in terms of units, F, V, P are the same. However, in terms of how to calculate, 7,500 ringgit is divided by 150 ringgit, which minus 12 ringgit, which in turn we can get around 50 ringgit, 54 ringgit per unit. Okay, now we are at the break-even chart. So as you can see, there is a box, a red box that calculates how much it costs to produce 54 units, which is around 93,750 ringgit, just like before. And if any of the lines ends in the box, it is count as loss. However, in this case, here we have a profit, the profit of TC RM 7,512 ringgit, TR total revenue, which is around 150 ringgit, VC variable cost, which is around 12 ringgit, and FC fixed cost, which is around 7,500 ringgit. Next is the environment and sustainability effect. Firstly, there are two effects. Firstly is the method. Cell phones can be recycled at the end of their life because cell phones contains a variety of material, including metals, plastic, and some valuable components that can be extracted and reused. Next is the analysis impact. Electronic waste is a global problem, mainly because many developed countries, such as the US or maybe the UK, send their discarded electronic devices to less developed parts of the world. For example, the Middle East or maybe Africa. They are unloaded or burned improperly, producing toxic emissions that are harmful to landfill workers, children, and nearby communities. Because of this, it can lead to long-lasting effects onto the population. Next, we reach the discussion part of the presentation. On the left, we have the design efficiency for old design and the new design. For the old design, the design efficiency is at 21.64%, while the new design is up to 33.33%. Obviously, the old design has less efficiency than the new design. So in short, the new design is better than the old design. That is for the design efficiency. Next, on the right, we have the assemble time for both the old design and the new design. Old design, it takes up to 386.5 seconds to assemble together into one unit, whereas the new design, it takes up to 202.6 seconds to assemble. As you can see, the old design takes longer to assemble in terms of the new design. Because of this, the new design proves to be better because we can save time when assembling it. Next, we reach the assembly cost on the left side. For the old design, it is 0.424, whereas the new design is 0.271. Therefore, users or manufacturers can save costs to buy spare parts. And the smaller the number is better to consumers and also manufacturers because they can save money also. And on the right, we can see the total number of parts for the old design and the new design. As you can see, the old design, there is 18 parts in total, whereas the new design is 14 parts in total. This is due to a lot of parts being removed or being combined with each other. And so, as you can see, the new design proves to be better because we can save time to assemble the product together faster than the old design. And so that is the end of our presentation. Thank you for listening from our group. Thank you.